Hello there, kids, and welcome back. It is now 30 days of September. Oh, no, not yet. It's almost New Year's. Now, New Year's happens. It starts in Japan, and then it moves around. So I'm gonna have my New Year's before yours, well before. So I can give you a heads up on how the new year is doing before it actually happens for you. We're a little bit advanced here in Cambodia. Now, as I mentioned before, there might be some lags in the output of these videos due to my continued obsession with wallpapers. However, I haven't really made a new wallpaper this time. Although, I did go a little bit crazy with the idea of the icons and the folders. To give you an idea of what I mean by that, here is my D drive now. Yeah. So this actually sets, if you look at it in, you can't look at it. Oh, there it is. There. See, CPP. It says CPP for C++, but really it should be all types of code. And here's another CPP. I thought the link made it easier. Well, no, I don't like this icon, but I'll change it. This goes well with Java. Music, perfect, which breaks down into audio, video, and well, this part has to do with like where I link things that I might be sharing. Lectures and interviews. So things that I get from YouTube. It's pretty hard to find a good YouTube icon. And the nicer they are, the worse they look at this level. You got to look at the icons in the. I guess this is 16 by 16. Now some of them, this one I don't think is. Yeah, it's not scalable. It's a low quality one. But I wanted. I tried a higher quality one, and because they put in so much detail. Well, actually, you can't tell at all from the higher quality one what the lower quality one will look like. Here, this is actually just a straight low quality thing. This one looks the same and can be no, it can't. Some of them will resize. Not that one. No. This will. Now, see, this is a high quality icon. But the low quality one is a completely different picture. But it's a good picture. It looks like something where you would temporarily jot something down. And that one's scalable. See? So some of them are scalable and some of them are not. This is a nice one. It's scalable. And it's not that, it's 16-bit version is not that great. But I couldn't find something with, well, actually, to tell you the truth, I did find something with tools in it. Just recently. Not there. I'm putting them all in a different location now. Green arrows are always documents. Pictures are always like that. Icons are always like that. Somewhere in here, that's some tools. Is this it? That's keys. See, at the low level here, there's a screwdriver. Now see, this has almost sort of scalable thing, but there's a better one. Here, a hammer. Now this is obviously not scalable. Small picture. This one might be. No. But it's not that. No, but that's a hard drive behind it. I could use this. No, but then it's got that red circle. Thought I found a more screwdriver type thing. I'll find all the ones I need. This looks sort of like tools. That's the one I'm using. Now for a temp, I was thinking of maybe using a rubbish bin. And I thought all of these were the same. It turns out some of them are just like that, and some of them, not that one, this one say, the small picture is actually no better, it's even worse than this one, but this one is scalable, so it would look good in a big view. This is the better YouTube. I think I deleted the other one. And this is a pretty good note thing. I think that's the one I'm using. There's another one. I was thinking of recycle for temp. I guess these are the same, aren't they? Delete one of them. No, it's not really any good for anything. This was the idea for temp. A folder for temp, not util. A folder with the recycle for recycle, or maybe that. Not sure. It's quite fun to change the way things look and feel. I find. No, that's not what I wanted to get. Oh dear. Cancel. But it still looks like a box of tools. It's fine. One of the things, okay, on the plus side, before I begin ranting about all of the terrible things in the Windows world, I figured out I partially figured out their secret. You see this, my documents, I made this myself, in temp, okay? But there's nothing called my documents in temp. See, it's called documents. I'm trying to make things simple by just copying the same words. And there's a junction called my documents in temp. Now here's the weird thing. Well, at least at the command line, you can't hide this here. You have to use Explorer to do that. Now, in order to get this thing to somehow it bound with the name of this, and it's something in this ini file that does it. Now, I don't really understand what all this stuff is, but I can see that it's taking okay, here's where it gets the image from. Now there's icon resource and icon file. Now, see, that's different from, I've been making these icons, and by the way, for that one, for my junction, I had irreparably damaged this junction by changing its attributes. If you change the attributes of one of these junctions, it stops doing this. All this information disappears. And I should have known that because I'd read about junctions before and how it's, you have to be careful because it's implementation specific. There's nothing general you can say about the way a junction is implemented. So you don't expect the regular functions to work. So when I tried to apply an icon to it, it got the icon, but everything else got wiped out. So I had to make it again. However, in C here, this is not a junction. And I never put this name on this. If I get rid of that desktop.in, well, first I gotta unlock, I think it's hidden. Okay, but you're still not going to see it, I don't think. Now if I just get rid of it, go back here. Now it says documents, which is the regular folder that was there. Now, I don't know how I'm going to unhide the junction. I suppose I could change. No, but see, now it's changed its name. It didn't just change the picture, it changed its name too. Now, where is that? Let's do that. Recycle thing. Come here, open up. Restore that. Now it's called My Documents, you see? And what was in that file again? Resource name. Perhaps this is a string resource with this identifier. Icon, resource, and icon file. I don't know if that's if there is such an icon in shell 32 DL, that's where it says it's from. It says shell 32, that's this. It probably is one. The reason it doesn't have the link thing is because it's not a junction. So that's how you do it. You gotta hide the junction. But in my case, I can't do it because there would have to be a directory that's specifically there to take its place. Or at least something that's a subdirectory, I guess. Well, all the ones in the home directory, I think, that you can see are actually in that directory. So that could be it. Where's the one that it's using? Well, I'm sure it's in there somewhere. It doesn't matter. So this is just a regular directory, and somehow through this sequence, which is not the same as just setting an icon. Setting an icon is different. Like these backups here also, because it has an icon, it has a desktop.ini. See? Here's the icon, resource, and the view state. So it's missing all that other stuff in the class info. I don't know what it means exactly. Now, not having a new wallpaper to show you, I figured that I would revert to my stamp collection, and maybe I could just, like mention one of the characters involved in this collection. And I was thinking about, I thought I might say something about Galileo, but Tycho Brahe, I don't know if you know, and many people are unaware of Tycho, who was Danish, by the way. He was a Danish nobleman, and particularly famous for his character. I mean, besides the enormous contribution to science that he provided, he had an odd character. I had some pictures of him. I was going to make an actual background, just with Tycho, and I have some pictures. Now you have to understand a little bit about him. Here's a statue picture of him. Okay, here's one of my peeves. But first, let's look at the picture. Let you admire Tycho for a while. Now, there's a reason why he's looking up like that, and that's because he pretty much tossed away his entire life staring at the sky. Like all of it, 20 years anyway, in his day, 17, whatever. People didn't live much longer than 20 or 30. But he was a nobleman, so I guess he had a better diet maybe than most. One of the things he was famous for, besides being kind of a hard-nosed realist, that is, his attitude towards the world and the way things, the way people thought, was that you can only really understand something if you look at it with as much accuracy as possible. And people had a lot to say about, the sun and the stars and so on. And at that time, everything was based on Aristotle's point of view, that the Earth was the center of the universe, and that they had this model of these concentric spheres with the planets being pushed around by angels, and so on and so forth. A very intricate model, if you've ever seen a model of that view of the universe, has within the wheels other little wheels which would explain away why the planets moved in the funny way they did. But Tycho was not about to accept any fairy tale notions like that. He thought that the only way that you can understand something is not by speculating and fancy party talk, but by actually looking at it. So he was like, I used the term hard-nosed on purpose because, and I don't know, maybe this is where the term originated. Because you see, Tycho Brahe didn't have a nose. Well, he did at one point. But he got into a duel, being the kind of person he is, got into a fight with someone and lost his nose. So he always wore a replacement nose, which some people would say, would have you believe was a wooden nose, but actually it was made of, I believe, copper. And I have a picture of his nose. Well, I don't know if it's his nose in particular, but it would have been something like this. And it would have been quite hard, you would think. So maybe that's what they mean, because he was a hard-nosed kind of person. Well, what we say hard-nosed means like, no truth without evidence, and no fancy talk. Show me the goods, and I'll tell you if I believe you. Sort of hard-nosed, that sort of thing. The way people think of science as being. Now, so he was not a people person. He wasn't a people person, and that explains not only why he got into a fight and lost his nose, but why he accepted a commission to sort of go and take over a tiny little island called Venn, H-V-E-N-N, where he set up his observatory, and he planned to show one way or another whether or not Aristotle's system, view of the universe, was correct. And he believed that the only way you can determine that is by observation, not by fancy talk. So he observed. He observed and observed and observed every single night for 20 years, all along. He went down into, and now this little island, then, I don't know if I could bring up a picture of it. Is very windy. It's kind of barren and cold and windy, and hardly anyone was living there then, and I'm sure that's still the case. And it's in between Denmark and Sweden. Between Sweden and Denmark, on Brahe. Oh, H-V-E-N. Oh, I put too many N's. It's a pretty desolate looking place. So there was nothing really much else to do than go down into a hole every night and stare up at the sky. And he compiled a massive amount of data on the motions of the planets, of the stars and planets. For one thing, in keeping with his goal of destroying anything Aristotle ever said and wiping him off the map, he discovered he was the first one to discover a new star in the heavens, or whatever you call it. Oh, but see, now there's that's actually a bigger one. You could make a wallpaper out of that. I have to stretch it slightly. I'll save it. Now this must be right by his right near his observatory. You can't see the observatory because it's underground because of the wind. But he never lived to see the fruits of his labors realized. The fruits of his labors were realized eventually. Here's the Here's the Aristotle view. Maybe I can get a bigger picture of that. It has the sun at the center, and the planets go round. That's supposed to be Earth, I think. Whoops. Okay, well, whatever. And it's like it's a quite an intricate little machine. If you've ever seen one working, got all these little wheels and things. Yeah. Well, anyway, Aristotle claimed that the sky was perfect and unchanging, and that was self-evident, and so therefore a new star forming was not within the realm of possibility. But it was a new light in the sky. It hadn't been there before, and suddenly it was there. And it was definitely a star because they knew about distances and parallax, and it had no parallax, and so therefore it was not within the rings. That model, that image doesn't show it very well. It has different rings, and there were 5 known planets, so there were, I guess, 5 rings, and then one great big outer ring, which is where the stars were, because they didn't move. You see, makes perfect sense, and you would just believe that because that makes perfect sense. It's self-evident. Here it is, desolate wasteland. Oh, there's this observatory. What else? Oh, I know what this is. It's flicker. Whenever I bet it says flicker. Flicker, see? Now, to get these ones, you gotta go to the thing. And you gotta find it. Unbelievable. But there's another way. I found a way. Anyway, that's a waste of time. Alright, so I was going to make a background with Tycho in it because he's such an important figure. Eventually his assistant, a guy by the name of Johannes Kepler, you've probably heard of him, used Brahe's data to come up with his famous laws, and ended up looking at this page to try and find the tables, like of all the data that Brahe had collected. And at one point, I was on this page, just there, this page, and I thought, well, okay, this is by Kepler, but it's based on Brahe's work, and so I thought it'd be nice to have that picture. And I got the large one, and I tried to get this very large one, and look what it said. Page not found. And but I knew it must be there somewhere. So then I went to the Wayback Machine, and way back in 2007, I found that page, and it did download. I did find it from there, so I managed to get that. So that's good. And so I was trying to make this background. I'm not really going to get to the tutorial part, am I? I made the background, and sorry, I didn't make the background. That's the problem. I couldn't make the background because because I got on this diversion, but as I was going through this page, and I've lost where it was, I ended up looking at Kepler's equation, right? and you can see whoever's made this page hasn't completed it, right? It says need diagram for this. I don't know if he means this or a picture. And then I started making a diagram, and while I was doing that, I looked at, was it this? Yeah, logarithms, and they were talking about logarithms and how that aided Kepler in analyzing Brahe's data, right? Because the thing is, there was so much data, and the observations were made nightly, right? So things don't change very much from one night to the next. So it's very, we're dealing with very small changes, right? And lots of very small changes. So that would allow one to draw a nice smooth curve of, let's say, how a planet moves around. And now they do this using this, they do these calculations using something called spherical trigonometry, or spherical triangles. Like you're dealing with these things called spherical triangles. And what's a spherical triangle? They are triangles that are on a sphere. All the lines, now on a sphere, if you start from the center, it's my better picture maybe. No, it's the best there is. To go from point A to point B, right, the shortest distance is what they call the great arc, which means that all these points along here are equal distance from the center. You follow the radial line. To go, if you wanted to get from here to here, and you went this way, right? In terms of the geometry of a sphere, that's not the shortest distance. It has to be what we call a geodesic. And so these triangles are triangles made up of geodesics, great arcs, which can be of any size, but there's still a geometry, and there are rules for the geometry. Like, for instance, here's the cosine rule. But strangely enough, the sine rule for in spherical geometry is the same as the one for regular geometry. If you remember from school, that's the sine rule, no different. And that's why, well, when you're trying to deal with all these little triangles, spherical or not, you're dealing with sums and quotients, right? And if there are many, many things, then if there's a little bit of error, no matter how accurate the data is, it accumulates. The error accumulates quickly if you're multiplying. If you're multiplying things and there's a slight error, then that error goes up quite quickly. But addition doesn't have that problem. The error in addition increases in a linear way, and taking logs of things changes multiplication into addition and division into subtraction, so the error is greatly reduced. And so Kepler was able to find out the precise equations that describe the motion of planets. Now, why am I explaining all this? Because it reminded me of something, and and all I wanted to do was I had this picture a long time ago that had to do with these sines and cosines, not this rule, but the addition rules. And it's a really beautiful little proof of the addition rules. And I looked and I searched through my drive. I couldn't find it. And it must have been on the old server that we had, our old server, and I lost it. So I thought, well, it's only, all I gotta do is draw a triangle. And I know the proof, I just, I'll just type it in with Notepad. Once I get a picture of a correct picture of the triangle, no problem. All I gotta do is draw in the rest by hand. And I tell you, it took me hours with this stupid Paint Shop Pro. First, just to draw a triangle. I'm not going to go through the hell of it. Eventually, I found out a way to draw a triangle, but I couldn't draw a right triangle. That's what I wanted. It doesn't allow that. No right triangle. Sorry. At least not if you're drawing a triangle. You can draw an what do you call it? Equilateral, with two sides are the same, and maybe the baseline is smaller, and it's easy to construct a right triangle from that. But I didn't do that. I thought that if I'm going to draw a right triangle, I should be able to do it. I was getting mad at the program, and I wanted it to be able to draw a right triangle. So I, typical fashion. Now what's happened? Now I've lost. Now this is all messed up. Okay. I get the paint dropper, if I can find it. Set this to white. Fill it up with white. This can go back there. Okay, no problem. Now, if you could find anywhere on these menus the shape, like the basic shapes menu item, then you're some kind of genius. The way I found it eventually was I went into the options, and I went through looking through the keyboard settings, hoping that maybe there's a key, at least there might be a key sequence that brings it up, right? And even though I can't find any menus that has it, possibly maybe. And I found out that if I select this and I press just the letter P, there it is. I know of no other way of bringing it up. And this has a triangle somewhere here. Only one type. That's the kind you can make. Now, how do you make a right triangle out of that? Well, you can just draw perpendicular and cut off the rest. But I figured there must be a way. And this is my method. First, turn it sideways. Now it's going to be one way or another. Here. Okay. Now that looks almost like a right triangle. Now rotate it back. See how close I am. Almost. See, when they both look like perfect straight lines, then it's a right triangle. I didn't go far enough. Almost. I'm going to pull it down a little more. Because the proof is quite elegant, and it's concerning right triangles. And you'll know if it's a right triangle because these will line up. It's not, it's off slightly that way, so I think I went too far. It doesn't even have to be perfect. I just got mad at this stupid program. For all it's worth, you can't even draw a right triangle. Come on. Finally, I managed to get it to almost exactly a right triangle, and I started drawing it. Like first, I'd draw the way the proof works. If you make a triangle, and you need to draw a box around it. See, you need a box around it. Now I've gone too far the other way. Yeah, almost. Whoops. Like, just imagine 2 hours to locate that thing. And by the way, once it's gone, and it'll go away if I click use something else, it's gone. See, that's no longer the menu with the shapes. You can't find the shapes in there. You've got to. This has to have the keyboard focus, and then you have to press the letter P. This doesn't work. No, nothing can, stretch it out, nothing, right? Nothing in the menus. Anyway, so you draw a box, and then what you do is you take this triangle, if you can grab it. No, that's not this grab. And then you rotate it by some number of degrees. Okay, and then you draw, then you take this box, and just by doing that, you can write down a very simple proof of the law for addition of sines and cosines. So I started working on it. Then I go back to here, and now I need a square, which is rectangle. I need a rectangle. Whoops. It's got to fit around here. Whoops. I'm going to make it bigger first. I'm trying to get this all perfect. It should come out square if you've done it right. Right, okay, now I've done that bit. Now I need a circle, which is really an ellipse. And then, so I want to draw some arc lines. So I need a circle. It's got to be centered here. And it's got to be a circle. Now with the circle, see, I can flatten everything down and erase all the rest of the circle, and I have one of these. Then I needed another one here and another one here. And it's taking a long time, right? And I thought, I must have that picture somewhere. And lo and behold, on Facebook, I had used it as my profile icon, and they still had it on Facebook, and I managed to download it. It's you're going to appreciate this anyway. You should, if you like math and that sort of thing. I must put it in my pictures. Or backup, that's where I put it. So I won't lose it again. and I called it angle sum. What initially it was a gift, so it didn't have these artifacts you're about to see. Now this is doing what I've just done. You start with that any old right triangle with whose angle, this is for the acute case, whose angle is A, and rotate it through an arbitrary angle B. Okay, so here's A and B. Now to prove this, the sum theorems, okay. Oh, and its hypotenuse is with unit length. Make things simpler originally, and all you've done is you've rotated it and drawn a square around the rotated triangle. Now it's simple geometry to work out. This B has to be the same as this B, right? And this total angle, because of the way this is, right? There's nothing to, well, that's this angle, right? So that's opposite. This is A plus B, so you can do this. That theorem, opposite angles are equal, so this angle equals this angle, right? If this is a straight line and you draw a line through it, then this angle has to be this angle, and we know this angle, and we can even work it all out very easily. That this has to be this angle has to be the same as this angle. Okay. Now, well, I guess that's the crucial bit because we're doing something with the sum, right? All right. Now this is length 1. This here, this distance is 1 cos A. So this distance is cos A, right? And this is sine A, right? Because the hypotenuse is 1. Okay. Well, this one's sine A. Now this angle is B. So this is sine A times cos of this angle. So sine A cos B. And in similar fashion, this here is cos A. And it's the sine of B times this. So sine cos A sine B. So this sum, therefore, has to be the length from here to here. But now this here triangle is a right triangle. And its hypotenuse is 1 as well, right? And its angle, if taken from here, is A plus B, if you can manage to figure that out. So therefore, this whole distance is sine of A plus B. So therefore, sine of A plus B has to be sine A cos B plus cos A times sine B, and so on. And that was that for that. How much have I used? Okay, well, we'll call this a human interest story. I didn't get to any code, so it'll go in my blog or rants or whatever. At least I got out of my system the fact that I hate PaintShop Pro, and I found out the secret of the junction that's not a junction, that's for whatever reason gets a new name. And what else did I want to rant about? Maybe I can get one quick one out of the way. Well, oh yeah. Now see, that originally, one of those pictures, this has probably happened to you too in your life once in a while. This here, one of these is a GIF. Where is it? That's JPEG. I can save it as JPEG. Oh, here. Okay. Now, when I double clicked on this, it didn't bring up, but it does now, this image viewer thing that instead it brought up the Corel image viewer, which I don't like because it takes forever to start up. And there's no you can't view full screen or anything. It does have a zoom thing, right? I thought, well, maybe that might work in full screen or something, but it doesn't have a full screen view. So I got mad, and I wanted to associate this with GIFs with this, what I thought was a program, but it's not a program, and that's what bothered me. There is a thing that says open with, right? And then now this thing didn't come up as an option here. And then I went choose default program. This wasn't here. Now it's there, right? And I didn't realize that I could find it down here, unfortunately. So I thought, okay, well, all I'll do is I'll run something that does use that. I have no idea how to find where the program is. I searched program files, everything. Then I double clicked on a JPEG, and then first I did like PS list and anything with like view or something in it, and nothing came up. Or image or IMG or nothing. So I thought that's impossible. It can't be, right? So then I have the thing going, and I want to see it. I know that SpyXX will tell you the process, right, for a given window. So I do that. Okay, I'm going to get the window, no problem. Properties, process. 1E18. Now what could that possibly be? And it won't do anything, right? Oh, no, didn't get there. Because this thing didn't bring it. Oh, here it is. Okay. So that's the process. DLL host. Yeah, I don't know if you know about DLL host. But you know how you can put code into a DLL file, right? And then execute it. If it's you could take your own program, whatever it is, and put part of it into a separate DLL and execute that part of the program. You would separate it from your main program, and maybe that's good for organization or something. Or another thing you could do is just write a general program that executes arbitrarily some function in a DLL. Of course, through the component object model interface. So, what's the command line for this? To get the viewer up. I'm trying to figure out what do I have to specify in the run as thing in order to make a GIF use this non-program. Oh, I wanted that up still. Alright. prompt text. So I find the DLL host wherever it is. Now look here. Okay, here it is. Here's the command line. Then process ID, and then you give it some COM identifier, right? That means it is meaningless, and the COM class, it turns out, is if you saw there, photo viewer DLL, but you can't run photo viewer DLL. You need to use the COM. Anyway, that bugs me. It's a program. Make it a program. It doesn't have to be complicated. Eventually, I found out how to. Well, I found out that that drop-down list contained it. But before I found that out, I managed to do it before I found that out through Control Panel to associate a file type with one of these registered non-programs. Now, how did I do that? This is maybe useful information. I think I must have gone to the categories. Change the theme, ease of access. No, that doesn't look right. No, that must have been that. Something else. I'm probably staring right at it. Personalization. Oh, here, default programs. That's the one. And then this one, I think. Or maybe this. One of these two. Let's try this. Ah, yes, this is it. It looks right. Takes a while to start out. And then you can find that, because that thing has been registered, it will show up in the list. That, not DLL host. That DLL host is generic. It's always there. But the component object for that Windows viewer. No, this wasn't the one I was in. I must have gone to this one to get a list by program, but not by file extension, but by registered program here, and then choose default, and then I select it. Hey, it's gone. It's gone away. See? Next time I reboot, it's going to be back to. Thingamajigamy. I don't want that. Anyway, it's working for now. I know how to turn it back. Oh no! See, look! I just turned it on. No, that's right. That's right. It didn't work. It didn't work, and then I got mad, and this thing won't even close. And I went back, and then I discovered that you can change it. That there are more selections. See, it's not closing. See. What did I call it? I have a batch file for this one too. Oh, it's gone. I can do that, but I found it in here. Okay, now it's fixed again. Alright, so this is it. I'll put a warning in the title. Nothing to do with anything. See you. Well, of interest, but maybe not to you.